Hello, this is the May 2018 paper again for semester 8. This is 3, part C. It's about the non-homogeneous Poisson process. And the question 3C is, the non-homogeneous Poisson process, formula for the probability of events in the time interval between T1 and T2 is given by this large equation here. This is sometimes written at the back of the exam paper as well. The probability that n events will occur within the time interval T1 to T2 is given by mu T1 to T2 to the power of n times e to the minus mu of T1 T2 over n factorial, where mu is between T1 and T2 is the average number of events in the time interval T1 to T2, or the expected number of events. The thing about the non-homogeneous Poisson process is that the average rate of events changes with time. That's it, right? And here, to find the average rate of events over a time interval T1 to T2, it's the integration between T1 and T2 of the arrivals rate, or whatever the average rate of occurrences over time, and u is a dummy variable. And this lambda u here, this is lambda t in our question. So for a particular process, lambda t equals 2e to the minus 2t, where t is in units of time. So part 1, determine the average number of events in the first 2 units of time. So basically we just have to find mu between 0 and t, which means we would use this formula. Okay. Part 2, find the probability that there will be more than 2 events in the time period 0 to 2. So the first part was to find the average number of events. The second part is to find the probability. So for the second part we need to use this formula here, but we will also have to use this part of it, and we will have got that from part 1. Part 3 is calculate the probability that there will be more than one event in the time period 2 time units to 30 time units. So that means we will have to re-evaluate this, the average number of occurrences in that time interval, and then put that value back into this equation here. Okay, so let's start with part 1. Okay, so I've written the 3 equations up here. These 2 should be at the back of the exam book, but this one here is particular to this question. So determine the average number of events in the first 2 units of time, mu between 0 and 2. We're just going to follow this formula here. So that is equal to the integration between 0 and 2, so this is T1 and T2, lambda u du, so we're going to put in 2e to the minus 2u du, 2e to the minus 2u du, and integrate it. So if you integrate e to the minus 2u, we will still get e to the minus 2u, but then we have to divide it by minus 2, and there is this 2 here as well. So this 2 comes from the integration, and this is already there. And it is between the intervals 0 and 2. The 2's are cancelled out, and we're left with this minus here, minus e to the minus 2u between 0 and 2. So we have to put in the top interval first of all. So if we put in 2 for u, it will be minus e to the minus 2 times 2. And then minus, because we're subtracting the limits, and then again minus e to the minus 2 times 0, it's going to be 0, so we'll just leave that as 0. Remember, anything to the power of 0 is 1, so if we were to calculate that now, that is going to be minus e to the minus 4 plus 1. See what that equals on the calculator. Okay, so I'll just do 1 first of all. 1 minus alpha e to the power of minus 4 equals 0.9817 when I round it up. 0.9817. Write that again, 0.9817. And really for this type of question, you need to do 2 at least 4 decimal places. Otherwise you could end up with a probability greater than 1, just 2 rounding errors. Okay, so part 2. Same situation, find the probability that there will be more than 2 events in the time period 0 to 2. So we basically already have the mu part of it, that's this. So we're using this formula here. We already have mu between 0 and 2, which equals 0.987. That will go in there. And we figure out the rest. So basically, they're asking for the probability that x between 0 and 2 equals, will be more than 2 events, is greater than 2. Okay. This is the same, well that means if there are more than 2 events, that means it could be 3 or 4 or 5 or 6 or 7 or an infinite number. So we do it the other way. We use the sum of total probabilities and say that's the same as 1 minus the probability that x between 0 and 2 is equal to, well, if it's less than 2, that means it can be 1 or it can be 0. So that's one of them. Or the probability that the number of arrivals between 0 and 2 is equal to 0. So the probability that x is greater than 2 is 1 minus the probability that it's less than or equal to 2, which means less than or equal to 2, which means we also have to include 2 in this, doesn't it? Yes. Okay. Plus the probability that x between 0 and 2 equals 2. Okay, that's it now. So find the probability that more than 2 events. That's 1 minus the probability of 2 or less events. That's 2 events, 1 event, or no events. Okay, so we have to put this here into the formula up here now. So the probability that x 0, 2 equals 1 is going to be mu which is here 0.9817 to the power of 1 e to the minus 0.9817 all over 1. And the probability that between the time interval 0 and 2 there will be 2 events is going to be 0.9817 to the power of 2 times e to the minus 0.9817 all over 2 factorial, and then the probability that x between 0 and 2 equals 0 is going to be 0.9817 to the power of 0 e to the minus 0.9817 all over 0 factorial. So if we do these calculations, I'll start with this one, it's the easiest. First of all, alpha e to the power of minus 0.9817 equals 0.3746, 0.374 when I round it off 7. Okay, then this one where we multiply it by 0.9817 equals that 0.3678, and then this one here multiply it by 0.9817 again, and that and divide it by 2 equals 0.1805. So if you add these together and take them from 1, so when I add them all up, 0.815 plus 0.3747 plus 0.3678 equals 0.9230, and then it's going to be 1 minus that. So the probability that x between 0 and 2 is greater than 2 is equal to 1 minus 0.9230, which is 0.07695, so that's 770. And that's your answer. Finished. Now that's only C2. C3. Okay. For C3, it's calculate the probability that there will be more than one event in the time period 2 to 30. So we have to find the average for this as well. So we're going to get mu between 2 and 30, which is the integral between 2 and 30 of lambda u, which is 2e to the minus 2u du. We use u as a dummy variable for now, and that is going to be e to the minus 2u minus, the 2's cancel out, we did this earlier, and it's between 2 and 30. So that will become, u minus e to the minus 2 times 30 minus, because we're subtracting the limits, minus e to the minus 2 times 2. See what that gives us. Minus alpha e to the power of minus 60, okay, plus 2 minus, make a plus, alpha e to the power of minus 4 equals 0.0183. So that's the mu part, okay? Now we have to put it into this formula, but we have to read it again, that there will be more than one event in the time period. More than one event, so the probability roughly that x is greater than 1 is going to be 1 minus the probability that x is less than or equal to 1. Okay, so that's total probabilities. Okay, so in our case, it's going to be the probability that x between 2 and 30 is less than 1, is greater than 1, is equal to 1 minus the probability that x between 2 and 30 is equal to 1, or the probability that x over the time period 2 to 30 is equal to 0. Now we have to put these into the formula, this formula here, so it's going to be 1 minus, when it's 1, it's mu to the power of 1, so it's 0.0183 to the power of 1, e to the minus 0.0183 over 1 factorial, plus, if it's the power of 0, 0.0183 to the power of 0, which is just 1, times e to the minus 0.0183, all over 0 factorial, and 0 factorial equals 1. So that's going to be 1 minus, well, this one is just e to the power of that, alpha e to the power of minus 0.0183. That equals 0.98, that's pretty high. So this one is 0.98186, so 819, plus, and this one here is multiplied by 0.0183 equals 0.01796. We'd have to round that off to 4 decimals to this and hope that we don't get a number higher than 1. Okay, so that becomes 1 minus 0.0180 minus 0.9819 equals 1 minus 0.1231, which is equal to, well, that is the answer. One minus them is already on it.